third example with integrals with trigonometric substitutions. So let's start with, it says to start with x equals 3 sine theta. Therefore, dx is equal to 3 cosine theta d theta. So I'll start with a triangle. Get my triangle out here. And so if this is theta here, sine, if I divide by 3, sine theta is equal to x over 3, which means that this piece down here must be, what would that, 9 minus x squared. So therefore, I have got a cosine here, so I'm going to need cosine eventually. Cosine theta is equal to this, square root 9 minus x squared over 3. Okay, so we can start plugging things in now, I think. Let's do red, and we have integral of dx is 3 cosine theta d theta, divide x squared, which is 9 sine squared theta. Right there is x is 3 sine theta, square root of 9 minus 9 minus 9 sine squared x theta. Okay. Continue. We have pull out a 9 here. I'm not going to write this, but I pull out a 9. The square root of 9 is 3. That will cancel with this 3. And I'm going to pull out this 9 right here. So I'm left with a cosine theta d theta. Divide, same as sine squared there. And I'll be left with the square root of 1 minus sine squared. Okay. Pull out the 9, and the square root of 9 is 3, canceled with that 3. That's where that came from. Okay. 1 minus sine squared is cosine squared. So the square root of cosine squared is cosine. So I'll write that step real quick. Cosine theta d theta over sine squared. And that's the the square root of cosine squared. Equals 1/9 integral. This and this cancel, and I'm left with sine squared d theta. This will simplify to cosecant squared theta d theta, and this is straight from your formula booklet. That's negative cotangent theta plus c. I have a theta. I started with x's, so I have to finish with x's. So negative 1/9 is tangent is opposite divide hypotenuse. Sorry, opposite divide adjacent, which means that the cotangent is adjacent divide hypotenuse, which is the x here, plus c, and we're done. Yay.